You're listening to Don't Waste Water.
I'll put $10 million into this business on one condition. And that's one condition is that we find a CEO who's not an academic and not a scientist, and that we all agree on.
So you're kind of the 10 million guy.
I guess.
Pretty cool.
It's cool.
Hello, bonjour, and welcome to the Don't Waste Water podcast.
Adding TAML catalysts, our chemistry here, reduced the energy demand by 90%, made that system essentially 40 times more efficient. Over a 10-year period, we could reduce the overall cost of that system by over half.
I'm your host, Antoine Walter, and in today's episode, I'm delighted to welcome Roger Berry as my guest.
One investor once told me that the first question she asks any water technology is, do you have another way of making money? Because it's just the market is slow to change, slow to adopt, slow to pilot, expensive to get in.
Roger is the CEO and co-founder of Sudoc.
Up until 2 years ago, the conventional wisdom was that we had 70,000 chemicals in common usage. A study from Australia showed that we were vastly underestimating the amount of chemicals that were in addition in the developing and in Asia. And the number is actually over 300,000 chemicals.
Sudoc makes chemical reactions exponentially more powerful with their new TAML proprietary catalyst. For the best part of my water career, I've been dealing with endocrine disruptors. When I started at Suez, it was amidst the times when the Swiss regulation on the elimination of micropollutants was coming into force, and the elusive but existing European Framework Directive was from time to time offering us a window of opportunity, which led me to work on the first ever plans to remove micropollutants from wastewater in France, Switzerland, and Sweden. Yet, I was roughly 2 days old when I learned that the term endocrine disruptor wasn't something that was around forever, and that it was indeed coined by a trio of authors, Theo Colborn, Diane Dumanowski, and John Peterson Myers, in a seminal book they wrote in 1996, Our Stolen Future, as you'll learn from Roger in just a minute. I haven't read the book yet, but you'll find the link to it in the show notes if you're curious. And with a foreword by then Vice President Al Gore, a promise as strong as to establish scientifically the evidence of endocrine disruption, and the bestseller status, it is no surprise that it had an influence on the US EPA's regulation and research initiatives. That, in itself, would already be a tremendous influence to have on our sector's path. But it doesn't end there. John Peterson Myers, so one of the book's co-authors, if you follow well, also happens to be one of the co-founders of Sudoc. To that extent, Sudoc is really born under the best auspices, as beyond Myers, it boasts a surprising and impressive range of 7 co-founders, including the $10 million man, Roger Berry. Don't worry, you'll understand in a minute why I call him that. Roger is the kind of person that will genuinely send you some pictures of him alongside Nelson Mandela through the ages when preparing for the interview, and tell you right after you stop recording that his own role in the Northern Ireland Peace Treaty will be depicted in a play in the UK next year, which kind of places you a man, right? Now, what he's sharing in between is also gold, as we'll get to know what TAML catalysts are and how they work, how Sudoc's technology could reduce energy consumption in water treatment by 90%, how the company's dual business model benefits both the environment and their bottom line, but also the health impacts of emerging contaminants, some $1 million of received investment, mimicking the efficiency of human enzymes, but also long-term goals and vision. All of that starts right after I remind you that if you like what you hear, all I ask is for you to take this episode and share it with a colleague, a friend, your boss, or your team, and I'll meet you on the other side. Hi, Roger. Welcome to the show.
Antoine, pleasure to be here.
Actually, that conversation takes its root in a forum we attended together some weeks ago, the Blue Tech Forum. We were all having a blast, and all of a sudden, someone steals the scene and says, hey, by the way, we have something to announce. And that's you stepping in with, I think it was Nick from Pure Terra who was with you, and announcing that just signed an investment agreement together. So they were investing $4 million into Sudoc, right?
That's correct. As part of a 10 million extension of our first round.
I was trying, to look at which box you would fit in the water world. And that's not that straightforward. The best I could find was wastewater biocides. And you tell me if that makes about sense for you. That's a market of about $730 million per year, so it's not small. And if I'm right, that's the market you aim to disrupt. So first, is that the right box to put you in? And if not, what would be the right box? And if it's the right box to put you in, what's the problem with that box, which you believe you can do better with Sudoc?
It's one box. One of the powerful things about our business is we're really relevant anywhere you have an oxidation reaction. And one of the places where oxidation is important and becoming more important is in wastewater treatment. And this whole idea of the emerging contaminants that we have. Ironically, there's nothing emerging about them. They've been around for decades and decades. The only thing emerging is really our awareness of these contaminants. 90% of these contaminants in Europe really come from our personal care products and our pharmaceuticals. So think of all the antibiotics you take in your own household and how they end up in our water streams. And just as one example, there's an arms race between our biology and the chemistry of antibiotics in the sense that we keep developing resistance. And so the presence of these antibiotics in our water streams is a health challenge. And more governments are starting to say that we have to treat these contaminants.
But there are means to treat those micropollutants or emerging contaminants. So what's different in your take compared to the chemical way, the advanced oxidation process way, the UV peroxide, the ozone, or whatever way which already exists in the market?
Efficiency. So just take electrochemical oxidation as one example. Highly effective systems. And you have different companies in Europe, North America, Asia, all piloting and trying to train these systems. However, they use a lot of energy, just running all of those anodes and creating all of those electric reactions. In studies that we've done, not ours, but UMass Amherst, a university system in Massachusetts, using waste pharmaceuticals as a target example, showed that adding TAML catalysts, our chemistry here, reduced the energy demand by 90%, made that system essentially 40 times more efficient. And that has the ability to take that very specialized system and niche market opportunities and make it far more affordable and far more useful. Our modeling shows that over a 10-year period, we could reduce the overall cost of that system by over half.
What is the drawback? I mean, it's 90% better. It should fly off the shelf and you should just flood the market. So what is the drawback?
One investor once told me that the first question she asks any water technology is, do you have another way of making money? Because it's just the market is slow to change, slow to adopt, slow to pilot, expensive to get in. And so that's one of the reasons why I think as an investment opportunity, there's a benefit to Sudoc in that we have different ways of making money. So there's really two sides of our business. There's a cleaning product side, and then there's a water treatment side. And there's some areas where these kind of merge. One example, commercial laundry is very interesting to us, and also a space where water is very critical. And a lot of water gets used in that space. So we're not just relevant for treating wastewater, but we're also relevant where you have industrial applications that use a lot of heat, use a lot of water, and use a lot of chemicals. Essentially, we're a replacement. We're a way of making chemistry more efficient with less heat, less volume. In commercial laundry, we've had a couple of pilots, one of them in Salt Lake City in a small hotel. These are hotels that use laundry machines that are similar to the ones you have in your home, but maybe twice as big. We're able to cut the cycle time by a third, which means we can cut the chemical volume by roughly 25%. And we're able to reduce the energy by 60% and the water use by half. Those are remarkable numbers. And you're asking why they're not flying off the shelf? Well, I think they're about to. We ran that test last month. A new talent that we found is leaving a very big chemical company to join our small chemical company because he sees the value. He's been in the laundry business for 30 years. And it's those kind of validations when you're the CEO of a small company aiming to be big, that all of a sudden you see people taking bets on your company with their own career because they see that scalability. Those kind of points of trust people put into your business are incredibly validating and exciting.
So you have two sides of the business. The water business is your neat brand, and the
Yeah,
cleaning side of the is your dot brand, right? You keep on
that's
pushing
right.
the two, or is it like one was first to be there and then
Yes.
the other one was the evolution?
Well, Dodd is first. It's not easy, but there's a quicker take up for the market on the cleaning product side. So we're already selling, we're all making revenue. And one of the things that was very important to me when we started the business 4 years ago is to make this company a customer focused business. In water treatment, because of that long pathway, it's very easy to get into R&D cycles where the culture of the business becomes about constant iteration, right? Constant making the mousetrap a better mousetrap, constant piloting. And so having the ability to make very effective cleaning products allowed us to get customers, more than 100 customers. And we've just last week launched our first distributorship, which is the largest distributor to health and sports clubs in North America, called Petra A1. And so we're very excited now. Petra A1's sales force is selling the DOT product line to its almost 5,000 customers in Canada and America.
We'll go back into the developments of the company, but you mentioned you created it 4 years ago. Something which was unconventional when I looked that up is that you were 7 co-founders. How can you agree at 7 to create a company? And is it a bit odd, or is it like fully natural to be 7?
I think it's a natural evolution. The company started as an academic project, right? And really around the work of Dr. Terry Collins. And Terry's a remarkable man. I mean, just imagine if Santa Claus were from New Zealand and were as brilliant at chemistry. Terry Collins, in a personality, has a huge heart, wants to really save the planet. And in the chemistry that we do, came together to try to put the initial ideas of what Sudoc could become. They then met primarily through Pete Myers. So Pete Myers is really the convener of this group. He, 25 years ago, wrote the book with two co-authors, Our Stolen Future. And it was really the first book after The Silent Spring by Rachel Carson that put together this link between our chemical enterprise and how it's affecting our development as human beings. And a lot of that science has since been filled in. But Pete was very good friends with Hunter Lewis, who made a good amount of money in the finance business. And he was best friends with Terry Collins, who I've described to you as the father of our chemistry. And so Hunter came together with this founding group. And for better or worse, said, I'll put $10 million into this business on one condition. And that's one condition is that we find a CEO who's not an academic and not a scientist, and that we all agree on. They had a search, and this group of, at that point, 6 found me, and we went through a number of discussions, and it was just an honor for me. Since then, all of the founders have been incredibly supportive, but the company kind of goes forward in its other stage. We have a management team that really operates subject to the guidance of the board, but it's not like we got 20 cooks in the kitchen. It was a launch pad, and those are people who are incredibly bright and available whenever we want to call them, and incredibly supportive. But I think one of the really blessings of what Terry's done, which is hard for a lot of inventors and academics, is to say, here's my invention, here's my baby, and I'm going to trust you as a group of people to build this business. And, for the first 6 months, he kept saying, it's your decision, Roger, but here's a couple of ideas. And I finally said, Terry, let's make a deal. You don't have to say anymore that it's my decision, and I'll know it's my decision, and I'll always want your input.
So you're kind of the 10 million guy.
I guess.
Pretty cool.
It's true. We have so many chemicals around us. Up until 2 years ago, the conventional wisdom was that we had 70,000 chemicals in common usage. That was what everyone thought the number was. It was the official government numbers. A study from Australia showed that we were vastly underestimating the amount of chemicals that were in addition in the developing and in Asia. And the number is actually over 300,000 chemicals. And these are impacting human life. Other studies have shown that male fertility, which is just easier to measure than female fertility, has declined by 50% over the last 50 years. So what that means in practice is that the sperm count of my son, not to be too blunt, would be half of that of my father. That's a generation change. And it's why so many of your friends and colleagues and mine, but more of yours, need IVF treatment just to conceive. And so this is related to the chemical enterprise that we have around us. And so Terry really set his 40 years of work to develop a more efficient form of chemistry. And he studied the way the active site of the peroxidase enzyme works in your body, and primarily in your liver. and creates a very efficient form of chemistry. So if your body practiced chemistry like we do in water treatment or in commerce, you would explode, right? Because it's so highly inefficient. It's so much heat, so much volume of chemical. And so essentially by mimicking and creating casings that could make this molecule stable outside of the human body, and that's really the source of the IP and the patent, we're able to create a far more efficient chemical reaction system. And that means we can do a lot more with a lot less heat, a lot less volume. And for us, now, when we're selling in commerce, that's not our sell. We just need to sell based on you saving money because you're not using as much energy, you're not using much other chemicals. But our mission really is a planetary mission. And that's really what drives us. It's what allows us to attract top talent because they want to work for something that when you get up in the morning, it matters, right? If you're reducing the volume of these very highly toxic chemicals that we use in the world and bringing them in balance where it's healthy with how we live, it drives our business.
So you're saying that the enzymes we have in our bodies are by definition more efficient than the chemicals, because if not, we would be exploding. But then you're also saying that what you're creating is even better than those enzymes because it's 100 times smaller and 1,000 times more powerful.
And ultimately, we're not an enzyme. So we're mimicking the active site of an enzyme. But around that enzyme in your body are these really long protein strains that make it a very large molecule, but also make it function within your bodily system. But outside, we've essentially captured the best of what that enzyme does. And when I say we, I mean Terry and the chemists that worked at Carnegie Mellon University. And they've created this, here it is. This is our little molecule right here. And, that's 1 gram. And if you were to take some tens of milligrams of this, it would allow me to create a 1 gallon cleaning product with 5 to 30 times less oxidant in that product. And that's the difference between that product being something that would burn you and being something that would be very hazardous to work with to something that's completely benign, but highly effective. We want to bring that same chemistry that we use in those cleaning products into the water treatment system, where we can extend systems like I described with electrochemical oxidation. We can pair with so many other systems, hydrogen peroxide, hypochlorite, electrochemical, and we think even ozone, and we're starting those studies too, and extend those systems and make them more efficient.
That didn't come out from the middle of a desert. If I understand right, I mean, your product is called new TAML.
Yeah.
So I'm going to assume
New
that
TAML.
there's going to be an old TAML somewhere, and then you're making a better evolution of that old stuff, hence the new stuff.
Yeah, so Terry's been working on this for over 40 years. And a previous version of the chemistry was effective, but had a one-to-one relationship between the effectiveness of the molecule and the lifetime of the molecule. And so the more effective version of the molecule you would make, the faster it would destroy itself. And so it was very hard to commercialize in a way that would be long-lasting enough to actually carry out a commercially viable reaction. It ultimately needed to have another iteration of innovation. And Terry was able to break that one-to-one relationship and create what we call new TAMLs with these protective casings around that active site that have made it far more effective, exponentially more effective than the old version, hence new TAMLs.
You expressed how it can work with different type of stuff, but if I understood your communication right as well, it's like the match made in heaven when you're using with hydrogen peroxide.
Well, that would be the most naturally occurring chemical pairing that we have. And we're effectively using that pairing in laundry right now. And there's a number of other benefits in the laundry space when we pair new TAML with hydrogen peroxide. And one of them is that we are really effective at preventing dye transfer. So one of the areas that we are very effective at oxidizing are any dyes. And so that means if we were mates and roommates and you put my red t-shirt in the laundry with your white t-shirt, the red t-shirt would come out red and your white t-shirt would still come out white. And the other incredible sort of benefit of this is odors. And so the chemical reaction is very good at oxidizing the root of odor. So I got a couple of kids who are pretty active tennis players. And so we were a great test case here in the house because they bring back some pretty filthy, stinky tennis clothes. They go off for their tournaments. They're away for 5 days. They come back and we have this pretty rich petri dish, and it far better than anything else we've ever seen. The clothes come out without like a masking smell, but they come out free of odor. And so if you take a pulp and paper plant, that wastewater stream is also pretty putrid in the sense of it smells and it's noxious off-gassing. And so those are areas, again, in water treatment where we can be highly effective.
But you said it from the very beginning that the water sector is not the easiest one to get something adopted. And I get the mission aspect of it, but from a business perspective, why do you venture into water if you have such a strong value proposition in the cleaning side of the business?
It really is core to the objectives and aspirations of the founders. Our mission is driven by making water resources exponentially better that we can do. So it's been part of why the investment has come. It's why Hunter Lewis invested in the company. It's why PureTerra invested in the company. It's why Momentum Capital invested in the company. And it's core to the mission of the business. We see these two things going very much hand in hand. The cleaning business, ultimately, it's all water, right? I mean, think about how you clean. Every time you clean, it's water. And every time we use water, it's the content of what's in the water that goes into the cycles of the circular economy and what we do. We're reducing the chemicals that go into water to begin with. With NEAT, we're helping extend systems to get those pollutants out of water so it can be reused.
So what is the scope of what you're offering? Is it like the catalyst we just saw in your little box, like you're a catalyst company, or did you also design some of the stuff which comes around the catalyst or even the system around?
On the cleaning product side, we are making our own products. They come in these small pouches, so we're not shipping water all over the earth. Instead of having a big gallon of liquids for doing your cleaning, you have a sachet of this chemical mixture. You pour it into a gallon of water on site, and you're spraying or using it in the cleaning application. In the commercial laundry, where we're talking about really large commercial laundry facilities using what's called tunnel washers, these things typically are like the size of a tennis court, that we're supplying DOT as an ingredient. So really think of our molecule here, but in a large kind of goes there and is mixed with water and then drip fed into the laundry system. And in water treatment, yes, we're basically taking the chemical, dissolving, and either dripping in as a soluble or as a dry ingredient into a tertiary, quaternary stage of the water treatment.
Coming back to what you're actually selling, my question is, how do you get it adopted?
Yes.
I'll give you where I'm coming from. When I'm discussing, usually with membrane companies, they all come up to the market with a new membrane, a new material, a new something, and they're like, that is really good. And then they can prove by A plus B plus C, kind of similar figures to what you say, that it's so much better in energy, so much better in removal, and so far and so on. But in order to get it adopted, at some point, they need to go up the value chain. Just because somewhere down the line, they will be able to be only a membrane company, but to start and to get the ball rolling, they will need to build a module, sometimes a system, sometimes do a pilot, sometimes stuff like that. Is it the same for you? Or did you manage to stay in your lane and say, no, we're doing catalysts and that's it?
It's not the same for us. And I think it's a business model advantage for us in that we're a simple drop-in additive. You don't need to change your hardware. Pretty much every treatment system is going to have a pump and a way of dosing in an additive. We don't need to make an electrochemical oxidation system. There's plenty of very good ones around there. And there are companies, we have one example, I can't name the company, but it's a very large company where they had a wastewater stream and they were using an electrochemical oxidation system, and adding our chemistry to that system brought that wastewater stream into compliance for water reuse. And without it, did not. Extending systems that are already very good, but extending them, making them more efficient to get over the line. So there's nothing that we need to build or construct or have a customer build or construct to bring the chemistry into a system like that. We want to be the world's first chemical company that you can love. If you think about it right now, if you think of all the chemical companies out there, can you name one that you really love, like you might love an Apple brand? But I think this is a company where we can attract mission-driven people because it's making chemistry better and it's bringing these systems, allowing water to be used where today it can't be.
Does that mean that you have like a reference list of all the electrochemical installations in North America, for instance, and you would start hunting them down one by one and say, hey, I don't tell you to switch, but if you were to switch, you would reap those energy benefits, efficiency benefits, and it's a one-to-one replacement?
We are. And also to be clear, this isn't magic. This isn't a magic potion where it's going to make everything for every target super better, but for a lot of targets it is. So there's some places where in electrochem oxidation, some particular chemical formulations, pollutions that we're not seeing those same results. So it depends on the water matrix. It's not a magic bullet where no matter what the system and no matter what the water matrix looks like, that we're going to be a home run. So it's a question as well of finding the right fits. But I would say it's not a niche market either. We are very good at a lot of things. That's why we're finding so much interest, both from the investor sectors, but also from large companies that are wanting to test us in these systems.
You're getting very good points on my scale of ranking by saying that it's not a silver bullet, but you're also opening me the door not to be the devil's advocate. So it's my time to be the devil's advocate. I used to
Go for
be
it.
in another life an ozone guy working for Suez, and we were developing ozone applications in China. And in China, we had a hard time because China has a history of catalytic ozonation. So very often we would bump into a project where we would say, oh, you have to go for advanced oxidation. And our Chinese counterparts would tell us, you know what? We have those locals doing catalytic ozonation and it's so much more efficient. So at some point, we looked into catalytic ozonation because we thought if they do it, we can't be so stupid. We have to do it as well. And so Suez developed a catalyst. The catalyst was super efficient. It was making catalytic ozonation super cool. The only problem is that it was crazy expensive. Yes, you were reaching super high removal rates, super high efficiencies and all the likes, but it was coming at such an expense that nobody was able to afford it. Now I'm tempted to believe that is just the downside of any catalyst, just because I don't know better. So now tell me better and tell me that you don't have that problem.
Well, we will not have that problem, but it's about scaling, right? And so that's why utility scale water treatment is in our sights for a 5, 10 plus year purview, because today we would not be in the cost matrix to make utility water treatment relevant to what we're doing. But it's a ladder. So what we're doing now is we are targeting those applications where we can deliver a customer at least a 2 to 3x ROI on the cost of buying our chemistry. And so in commercial laundry, that's what we're looking at. When you add up the savings in energy, chemicals, and water, and then the other fits of like the consumables, when you're putting less stress on the system, you don't have to replace the tubes and you don't have to replace other kind of everyday wear and tear items as much. And so we're getting more of those life cycle costs. But we're looking at essentially a 3-to-1 ROI for the customer. When you're looking at our cleaning products, we're essentially either on par with the cost of a competitive product or 10 to 20% less because of our shipping benefits. We're not shipping water around, so we're much easier to store and handle. It's not a pitch of, hey, this is a great green product, pay 20 to 50% more for it. It's a pitch of, this product will work just as well or better than what you're using today. It'll be the same price or less. And by the way, you can put 5 times less chemical into your environment and still get those benefits. We are right now, as we speak, beginning to manufacture with a contract manufacturing organization. In our world, it's all about the vessel size. So can you manufacture in a 1 liter vessel, a 2,000 liter vessel, an 8,000 liter vessel? Those are typically the scale of commercial. And the answer is we can, and we are. So we're now creating that many kilogram production schedule that will lead up to a ton production schedule, which will lead up to a multi-ton production schedule. When we're starting to manufacture in those many tons area, that is when our cost per kilogram is going to come into a zone that will make utility scale water treatment a viable market for us. But we're very consciously targeting these industrial markets, commercial laundry, electrochemical oxidation systems, because the impact that we have is still generating that 3+ ROI, even at the cost point where we are today.
I'm super glad you added that at the end, because if not, I would have questioned why you would even think of going to the water utility market. If Gradient's path has proven something, is that targeting only the industrial side is probably the best way to go at it if you're bringing a new water tech to market. And if you want to really waste your life, because the impact is great, but it will take your life, then you go to the water utility side of the business. So is it like your aspirational goal to one day be at the place that you could also go to utilities and it's part of the mission? Or can you be pragmatic and business centered and say, by the way, our biggest added value is on the industrial side. Why would we even venture on the municipal side?
So there was a guy who I really like, who was one of the top marketing guys for Nike. And then he went on to Lululemon and a number of other businesses. At one of his points of call, he was working at 7th Generation, and they made it a goal. The goal was for Target to call that. They set themselves their own kind of objective, which is we're not going to knock on Target's door. We're going to become so wanted that Target's going to be banging on our door. And they did it. So yeah, we're talking to utilities and we're going to all these conferences, but I think we want to create so many good use cases in the industrial sector and in the cleaning product sector and laundry and all these other areas where it's almost now becoming where the big giants will come knock on our door. If that happens, we know we're being successful. We want to get sales because we have proven commercial benefits in the market, not just that we went to the right conference.
So what's your approach to sales? Is it a per kilogram, per box, per sachet kind of sales, or do you have a recurring revenue, like people would get a registration and then you deliver regularly? Is it an espresso system? What's your business model?
We're selling chemicals and chemical products. You buy a physical product from us, and in the early stages where we're piloting or testing with people, they're essentially paying us for the catalyst, but also for our R&D time to be working with them to develop an application.
Does that mean that there's an off-the-shelf type of business and there's also a custom type of business where you would tailor the catalyst to be really suited to a special application?
So for example, we're working with a second tier but very large consumer cleaning products company in Europe. And they want to use our product in dishwashing, for example, because we could replace an environmentally not liked ingredient with our ingredient. Now, in this particular case, there's more science to be done. There's some surface chemistry applications that we need to work through. And so that work is being done right now at Carnegie Mellon University and also within Sudoc. And so that's an example of an area where we have a lot of evidence that this should work, but there's more chemistry to be done, and we invest some money to do that. In the water treatment world, we haven't seen too many examples where there's more chemistry to be done, but we do have an amazing R&D team run by PhD Matt Mills. And I think you've met Brady Steinbach, who runs all of our NEAT platforms. So essentially the two of them are an incredible duo to engage with industrial wastewater treatment, Brady on the application side and Matt really on the fundamental science side.
So there's another elephant in the room which I need to address, which is you mentioned micropollutants, emerging contaminants. You're a US-based company. US is known to be the first mover when it comes to PFAS regulations. And PFAS is nowhere to be found on your websites, which I found on one end reassuring because that means you're not simply taking all the buzzwords, because if you would, that would be the number one buzzword. But number two, I'm asking myself, electrochemical is known to be something which targets PFAS or can target PFAS. So is that somewhere on your roadmap, or you say, no, not really what we're looking for?
Two comments on PFAS. The first comment is that we do not yet have evidence that we help electrochemical oxidation systems directly. So the way that we may be benefiting these electrochemical oxidation systems is by taking the electrons from the anode. And so our catalyst then expands the field of attack and allows us to get more of the pollutants in the waste stream around the anode. But in that case, it's our chemistry that would have to be effective on the target. And we've not found our chemistry to be effective directly on those incredibly strong PFAS bonds. So that's just one of those areas where this isn't a magic bullet. It has to be the right target for the right chemistry. Now, that said, those electrochemical companies going after PFAS are doing tests with us because they see a benefit in using potentially our chemistry to get other things in the matrix so that you don't use the expensive part of the system on the other parts of the water matrix and allow the system to focus on PFAS. So we may be relevant to the PFAS treatment train, even though right now we don't see ourselves to be as relevant to PFAS. I'm all for us making every effort we can to get PFAS out of the environment. PFAS is not good. It's incredibly prevalent. We were renovating our house a few months ago, and the company coming in to do the shower doors was trying to sell me this great surface coating that would stop the water from beading. And I said, hey, can you check if this has anything with a PF in it, either PFAS or PFOA? The guy's like, I've never heard of it. Calls me back the next day and he says, no, you don't want this. So people are still selling it. It's everywhere. The complaint I have is not that we shouldn't be going after PFAS. It's that PFAS is overwhelming the dialogue about water treatment and pollutants. There are so many other things that we should be also talking about and getting: hormone disrupting chemicals, endocrine disrupting chemicals in our waters. We have effective ways of going after them. PFAS is a very important part of the conversation, but I just want to say it really shouldn't be the only part of the conversation.
I agree with you. Interestingly, your example of endocrine disruption is the parallel to the one I usually use. I didn't know the story about the change in fertility in men. I knew the stat about the change of the age of the first periods for little girls, because it used to be
Yep.
women and now it's girls. Because within 1 century, the age of the first period went down from 17 and something years to 12 and something years. I know we're a species which is able to evolve over time, but not that fast and not within 1 century. It's not possible, not humanly possible without an external help. And help is probably not the right word. Where I'm heading with that is that usually the counter argument I receive to that is, yeah, you're right, the stats exist and are probably true, but the contribution of water to that is probably low. Meaning that air pollution does much more, food pollution does much more. To which I say, yeah, but okay, if you tell me that, it means that you also believe that water has a role. And if it has a role, let's look at that role. How do you react to that objection to say, is it worth it? Is it worth running after those antibiotic resistance? Because, yeah, people are still taking the antibiotics themselves, so they are building the resistance without it being in the water.
It's the environmental context. I think it's usually an industrial defense to sort of try to isolate a problem and say, let's only think of it here. We are putting chemicals all around us in incredibly large volumes. And the antibiotics and the personal care products, all of these are containing very disruptive, endocrine disrupting chemicals. I don't know if you know this, but Pete Myers is the scientist who coined the term endocrine disruption. So this term that we use is actually at the heart of what the mission of our business is. And so I think water plays a huge role. Water is essentially a mirror of our society. So there are studies of Lake Mead where literally, depending on what convention comes into Las Vegas, it shows up in the water system. So the psychiatrists come in, and all of a sudden you see, psychiatric in the water system. Big gambling convention comes in, and all of a sudden cocaine and other class 1 drugs end up in the water system. You can't tell me that treating our water and making sure our water is safe, these are the same waters we're going to drink later in the same year. To me, it's just foolhardy to not say that water isn't part of the issue of how these chemicals are impacting our own development.
What you say makes objectively a ton of sense. I was just heading to something you said to me before we recorded, which is you were talking to me about that NABC methodology. So need, approach, benefit, cost, and then positioning yourself towards competition. And in that acronym, the first part is need. And that's where I have my question, my doubt, because a big section of the trouble we have in the water sector is that the need is not clear. And I think that's also something which I guess might resonate with you. We take water for granted, and hence the need to get it clean doesn't really exist because I'm opening my faucet and I'm getting water. We also take the way to treat water for granted. And so we don't need to change that unless there's a crisis. And then that goes to the theory of our good friend Paul Callahan, who says, whenever there's a crisis, then it moves. But you need that crisis to happen. Is there a way around to make people realize that the crisis is there, but without all the negative consequences of the crisis?
The European Union has put in its water directive the requirement that member states come up with plans to remove waste pharmaceuticals and personal care chemicals from our water systems. Is it happening at scale yet? No.
You have to let them time. They voted that in the year 2000. We're only in 2024. So what can you do in 24 years? Come on.
Right. Well, and that's why we talk about these issues. But our initial use cases are about very practical commercial use cases where our chemistry can simply extend systems. So we have a very long view, and this Sudoc is meant to be a company. My dream is to still be running this company, years and years from now, because of the number of applications that we have and where can we be impactful. But that's why we're focused in the short term on commercial applications where we are very fundamentally reducing energy, reducing costs, reducing system costs, and extending treatment where that's happening today, what we need to do with our water systems. Now, on the commercial side, and you know this extremely well, is water is becoming a fundamental commercial decision about where to site a business. The company I was referencing in the United States, where they had to come into compliance, it's about the need to actually have water to use in their business because of the lack of water. In India right now, there's a lot of movement around treating wastewater streams, not for environmental good Earth's good planet benefits, but simply because there's not enough water to run the business. So if you're not creating water reuse, the business isn't viable. And so in the medium term, that's where the need is imminent, right, is pressing. But I certainly hope from a regulatory point of view that they create that crisis around treating these endocrine disrupting chemicals, because we're using these other use cases, that Sudoc is around to be an answer to that crisis when that happens, whether it's 2 years or 10 years from now. But I also think, Antoine, your generation and the younger generations know more than our generations did. I certainly was, before getting involved in this company, blind to what chemicals mean to our life. But I think your generation and the younger generations are becoming far more conscious of what this is. And I do hope that you don't stand for it. You know, that the idea, if we were to run a blood test on you, do you know how many chemicals we would find today?
Too much, I guess.
About 600. We would find probably at least a handful of chemicals in your system today that have been banned for more than 10 years. We would certainly find traces of PFAS, right? We are carrying this stuff with us. I think we just didn't know. I certainly know now. My eyes are open. But I think more and more your generation and younger generations are aware and are going to vote that way.
I agree with you, which is the reason why I have to contradict you. Because that's the objection which I'm hearing as well, which is to say, yes, those emerging contaminants are not emerging. They are around for a while, but before we could not detect them. And so now we can detect them. So as we can detect them, we see there's a problem. I had the discussion with Christopher Gasson from GWI, and he was saying, if PFAS is in 98% of the people's body, then how dangerous can it be? And when I said that to Julie Blissmullen from Clarity, she said, yeah, we have all the proof to say it's carcinogenic and whatever you want. So she explained all of that. Right. But still, I have to say to Christopher's point that it's true that if I have 600 chemicals in my body, then they're probably not dead full, or I would be dead probably by now. It's also because we can measure more stuff that we get afraid of more stuff. And I had that conversation, not to name drop everybody, but with Amanda Sikora from Vapor. And she was saying that one of the reasons why people would not want to get to inspect their pipes is that if AI inspect their pipes, it will detect more defects. And they're not so much interested in all the defects which exist, because they'd rather not know, because ignorance is bliss.
It's a slow change problem, right? And it's very hard for people to react to slow change, right? So the volume of chemicals and bad chemicals that we have in our body is not a good thing, but it doesn't mean necessarily that it will kill you tomorrow, right? But what we do know is that it will have negative impacts on a significant percentage of us some period over time. And that's a bad trend, right? We don't want that trend. But then, because it's not going to kill you tomorrow, it's not pressing and it's not immediate and it's not personal. So yeah, we very sadly learn to live with this representation of all of this chemical enterprise in our systems. But I do think the statistic I gave you, it's a shocking one. Read Dr. Shauna Swan's book called Countdown that came out 2 years ago. And you mentioned on the male side, we believe it's analogous for women. It's just easier to measure in men. The idea that we've had a 50% decline in fertility in 50 years and that it continues on that downward trend. What are we doing? This is a challenge to our very
endogenic, exogenic. I mean, I also read studies which says that the problem is the diapers. Before, the diapers were not that efficient, and there's a reason why the male genitalia is outside, is because the male genitalia doesn't like to be too warm and too hot. And if you put diapers which are too tight, well, that's also part of the problem.
Oh, there's many aspects to the problem. Stress is another aspect to the problem. If you just look at stress in the male population, you would think that back problems would occur at the oldest age, right? And no, they don't. The majority of back surgeries happen in the mid 40s to mid 50s, and it's related to stress. You could extrapolate that example to fertility and other things. What we do know, and it would cost billions of dollars to research this to a scientific precision, but we do know that chemicals, endocrine disrupting chemicals, interfere with the hormones that are related to fertility. We know that the amount of those chemicals that interfere have been increasing exponentially. And we do know that fertility is declining. To say that there's not a relationship between the chemical enterprise and our fertility is foolhardy. To say that the only relationship with fertility decline is chemicals is also foolhardy. It's a matrix of issues, but I can promise you that endocrine disrupting chemicals are front and center of the problem.
I think you made the perfect analogy with the slow change. I'm French, open secret. And we have that reputation to eat frogs. Okay. If you cook frogs, you put them in water and you bring that water always a bit warmer until the frog can't move anymore. And yeah, it dies that way. But the frog is in the water the entire time and never wants to escape. So it's a bit the story we have here with the different type of metaphor. And with that ramble, I want to bring you back on track because you said you're building something for the future. And one part of what you're building is what we discussed in the very beginning, which is that you're raising money and you just closed a 10 million fundraise. Now, what's interesting with your path is that you've been raising $6 million from Momentum Capital. And if I'm right, you have been working with Momentum Capital. So, is it a bit of left pocket, right pocket discussing together? Or do you have an insider advantage when you have the discussion with them? Or how is it to be on the other side of the table?
I have a very much an insider advantage, and I'll take those advantages every time we can. This was a really nice round for us for a couple of reasons. So, one, Momentum Capital coming in is someone I've worked with before. We turned around a very difficult sustainable energy business in the Netherlands and Europe years and years ago. And so Martijn van Reenen and I and other members of the team, we were in very tough situations where we had to make sometimes ethical and business decisions. And we saw how each other behaved and operated. And we came away with a tremendous amount of respect for each other in going through those trenches together. And so them coming into our new business here brings partners who I've worked with before into this business who I think are going to make this business better. So that was really edifying. And then secondly, PureTerra, who we didn't know at all before, got to know us. They are backed by the European Investment Bank, the EIB. So they have the imprimatur of the European Union behind them. They are focused solely on water, and their due diligence is as probably detailed as anything I've ever seen before. And the amount of scrutiny that they gave us around our chemistry, our business model, our team, and our personnel, without having known us before, again, was edifying because they came to the same decision that this team and this company and this chemistry was investable and they think incredibly scalable. Sudoc just got better. We added 2 board members in Job van Schelven and Martijn van Reenen. And we had our first board meeting yesterday. And it's just great to see 4 years ago, this company was a white sheet of paper, and then it was a white sheet of paper and me and all, all the founders behind. And now it's a train that's gathering steam and bringing on the right people, both as employees and as board members. And so it's an incredible ride.
How many people do work for Sudoc today?
Full-time equivalents would be 12, about to be 14.
And what will you be using the 10 millions for? Hiring more people?
No, essentially extending time. We've had to build so much in the last 4 years: a production process, a lab, an R&D capability, a product definition, a product development team, and now a water treatment focus. And so we really want the next 2 to 3 years to establish the kinds of revenue that would allow us to raise a round that really takes us into being a global business. So I think in the next 3 years, it's all about moving from startup phase to scaling phase. And then in 3 years from now, it's really about developing this business as a corporation.
Will you be producing the catalyst in-house, or do you have a formula and somebody is producing for you?
We've just been running our first production run with a contract manufacturing organization. That's very important because that takes us from producing in 5 to 20 liter vessels to producing in 100 to 1,000, 2,000 liter vessels. And it's going very well.
Where I'm heading with that question, because you mentioned that, is if you have like a midterm or long-term plan to have your own production, then you probably want to build your business around that location. If on the opposite, you want to be the one providing the formula and then you have your partners which are building and producing a bit everywhere, then you probably want to gain market traction in all the different geographies at once, and the faster the better. So if I understand you right, your strategy is the latter.
So what's a big advantage for us, if we were to launch Sudoc 20 years ago, it'd be a very different proposition. And you'd probably need $40 million to get where we are today. And that's because in the last 20, 30 years, the pharmaceutical industry has developed a whole third-party manufacturing system. This infrastructure didn't exist 30, 40 years ago, but now all over the world, most pharmaceutical companies don't actually make their own pharmaceuticals. They do the R&D and they do the marketing to the customer, but the actual production is done largely third party. So we have the benefit of sitting on top of all of that infrastructure that's been developed. Now, we always will have an internal production capability to develop the synthetic process as we develop new variants of this catalytic system. So we will have our own production, but at least the way we assume it right now is we can benefit from the scaling of third-party manufacturing in order to create the cost benefits that we need to go to market.
I have usually a different way to raise that question, but I feel like I can be a bad guy and raising it that way for you, and I'm sorry about that. Do
Bring
you
it on.
have any chance of building that company to be big and bold before a Chemira, an Ecolab, or whoever snaps you and takes you as the cool chemical-free alternative to whatever they are doing today?
I think so. Yeah, I think we can become a very large chemical producer. Some of those companies that you mentioned could be very interesting distribution channels for us. We don't have to necessarily develop our own distribution channels to be the chemical company we want it to be. And so I think our focus right now is on the scientific proof and commercialization of these applications. And then we'll wait and see in terms of how much infrastructure around production and distribution that we have to create ourselves or that we can leverage other parts.
But when you're raising that round of 10 million, which ends up being with two venture capital players, you don't have at any point of time a conversation with telling you, I'm taking 5% today because down the line, I'm going to take 80.
We haven't sought that conversation out because we know we would like to develop our own leverage so that when those conversations happen, like I said, with that example of my friend Duke Stump, who was at 7th generation, we want to have them knocking on our door.
When I interviewed Fadja Mushtaq from Oxide, arguably another type of catalyst company, she explained how some of her employees, so some of the latest people she took on board, were part of companies which became unicorns in biotech, and that the fact that they were now jumping to Oxide was a sign that they were on the path to build that. And that's what you said about your latest recruit, which is coming from a big player coming to you because he or she sees that there is that broad, not only mission, but also path to scale at Sudoc. What brings you confidence that that's going to happen in the next 10 years?
I honestly feel that as a business, we really believe in ourselves. We believe we have a chemistry that is fundamentally different from other chemistries. And we've seen it in ways that impact people very directly. So, it's not huge scale yet, but in a smaller scale, when you sell our products to these mold remediator companies, and to understand what the business is like, I got into a crawl space with our partner. And a crawl space is about this high. And so you're in there and you've got these beams and there's mold all over the beams and you're wearing a respirator and you're spraying these chemicals. In order to get through these spaces, you're reaching and your skin becomes exposed somehow, right? Unless you're like an astronaut. And, the jobs that these guys do are just damn nasty. People who are doing the kind of the real difficult work in the country and why so many of them are dissatisfied because life is not easy and the job is not easy. And then you bring this product into that system. And, one of the guys is like, I no longer have to deal with chemical burns. Right? It's done. And it really is impactful. And then you look at the larger scale applications, and it's not my words, but this employee who's joining us, he says there has not been an innovation in laundry in the last 30 years that he's been working in this industry that even approaches what he sees that we can do. There's been nothing that's a game changer. There was a line in the industry. A guy was telling me, because I was calling a reference, he says, well, there's a line in this industry where it's not the chemicals, it's the rep, because everyone's got the same chemicals. And when he said that, I was like, actually, not anymore. Not everyone's got the same chemicals because we have something fundamentally different. And so, Stefan is joining the business because for him, he's been in this industry for 30 years. He's been grinding it out. He's in his 60s now. And for him, this can be a crowning achievement for his career in an industry that hasn't had change at all. So when you see those things, it's not just what I tell them, but when you have that conversation and you look at the science together and you see those kinds of results, I don't have to tell them a story. They're creating the story and it's building the company.
If I bring you back to the Roger from 4 years ago, you get approached by that team to be one of the co-founder and to lead the team of Sudoc. You have your own history. You've been working with Nelson Mandela. You've been working on this North Ireland peace treaty and stuff like that. So you've done things which belong to history books. And someone comes and say, I have a cool idea to do a chemical which can maybe change laundry. I'm painting it negatively on purpose. But what's the driver? What is that single thing that makes you believe is the right thing to do for you to take that plunge, to go down that route? And in retrospect, 4 years later, were you right about that?
Antoine, I'll tell you something personal. It was quite a moment in time for me. In 2020, as COVID was becoming a story, on January 20th, I had a pulmonary embolism after taking a very nasty air flight. And that's when you have a blood clot that breaks off. And if it breaks off big, it gives you a heart attack and you die. If it breaks off small, it goes through your heart and deposits in your lungs. If you don't get to the hospital within 24 to 36 hours, you die. So there's a 30% mortality rate. Thankfully, for my wife and my sister-in-law insisting that when I had this pain that we ran there. So I lived. And 2 months later, the conversation with Sudoc came to my doorstep. When I heard about what this could do, I spent the whole weekend. I put together this slide deck and I dissected what this business could be from every angle, from a regulatory angle, from the marketing angle, from cleaning products versus water treatment. Worked on it the whole weekend because I was so motivated about what the promise of this chemistry would be without having necessarily the validation of it yet. When we had our second interview, it was supposed to be a 6-week process and they cut it short. At that point, COVID is coming in and my lungs are compromised and we're all working from home. This opportunity lands in my lap. It's been the greatest thing ever. I've been working for 20 plus years, both on the investor side and on the business side of trying to turn around companies. This is the first time since 30 years ago when I did start my own company, but at a very small scale, where we've been given this IP and really a white sheet of paper. Anything that's screwed up in this company is my fault because it started there. And anything that's good in this company is because I got the right people to join the mission. And I have absolutely zero regrets about that. I'm so proud of every single employee that we have. And I know they could make more money elsewhere, maybe not in stock. They have to have faith in the stock options they are going to take them somewhere. But every single person working in our company could make a higher salary somewhere else. And they're here because they believe in what we're doing. It's been the greatest job of my life.
I would be tempted to ask so much more, but that is so much of a powerful conclusion to that deep dive. I don't want to harm the moment by going into something else. So, Roger, thanks a lot for everything you shared in that deep dive. To round it off, I have a list of rapid fire questions, and if that's fine for you, I would switch to that.
Oh, yeah, absolutely.
It's time for the rapid fire questions.
Okay.
What is the toughest challenge in your opinion for a water tech startup?
Survival.
What would be your best single piece of advice for the founders and managers of the about 1,000 early stage water startups?
Focus on an unmet customer need and not the technology you have.
What's the drop of knowledge you wish more investors knew about the water sector?
That water is climate change. 70% of the earth is water. If you want to affect climate change, you better address water.
What was your most unexpected partnership and what did it bring you?
Momentum Capital and a best friend.
So your first encounter with them, not the second.
Both.
Super short, profitability or growth?
Growth.
What's the next profile you'll hire?
An expert with 30 years of laundry experience.
When you hire, sector experience or startup experience?
Sector.
Opening new markets or doubling down on the current ones?
Doubling down.
So no third brand coming around the corner, which would be the continuation of what you did.
We're focused. We try to be focused.
What is that tool that nobody speaks about, but you couldn't live without?
Feedback.
What's the single piece of insight your ideal customer profile needs to hear right now?
Chemistry can be better.
What are you desperately needing and want to raise an open call for right now?
Time.
Who's the GOAT in tennis?
And Roger Federer.
Oh, shit. I was hoping to argue with you, but we agree. It's okay.
Although Nadal and Federer, my wife is from Spain, so I might have to change. I love them both. But do you play tennis?
Not to the same level than you do.
That's
But
good.
basically speaking, I have a friend. We are playing tennis together. Like we play for 5 hours because we're so bad that a single match always takes 5 hours, but we're having a blast. But if we play against anybody else, we lose, but we're having a blast. What can and should I do for you?
Tell our story. Tell everyone you know that we're worth talking to.
I guess they should be convinced by now, but where should I redirect them to keep contact with you?
rberry@sudoc.com, sudoc.com.
The links will be in the show notes. Check them out. It's up to you. You decided to share your email address. If you get spam, I'm not guilty. Roger, it was a pleasure to have that conversation with you. I hope to have a sequel with you when you hit the next milestone or when you raise your next round of 100 million or whatever comes first. Thanks a lot for sharing your path and talk to you soon.
It's been a blast. Thanks, Antoine.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.